let's consider, what about the ideal? What is the ideal profile? And that depends on what you want to do. Do you want to find the bugs fast? Or you want to estimate operational failure intensity? Which is your failure rate. Okay, so which one do you want? Do you want to find the bugs fast, or do you want to estimate what failure rate you will encounter during actual operation? Now, these are two different objectives. And some people have suggested that you should use operational profile. And operational profile is the profile that is expected in normal operation. So this is the mix expected in normal operation. So is this what you should do? Find out how the software is typically used and apply inputs that kind of represent typical operation. What do you think? Is that going to help you find the bugs fast? This is again slightly controversial, and we wrote a paper. So the conventional wisdom was that you should use operational profile, and operational profile would help you find bugs faster. Then it sort of makes sense. Okay, this is how people are going to be using it. So you should better find those bugs that people are likely to encounter. But it can be mathematically shown that after some initial testing, as you get towards higher reliability or lower defect density, it is better to not use operational profile, but rather use a more random distribution. So that went against conventional wisdom when we first did some work, and we had some mathematical analysis. You will find a link to a paper there. But then other people also said the same thing, that if you want highly reliable operation, then you have to, the faults that are remaining are the ones that are least likely to be detected, and hence they are less likely to be detected by typical usage. They would be triggered when you have some unusual combination. And if you want to trigger unusual combination, you're more likely to get unusual combination if you will use more random testing, or maybe do targeted testing. So operational profile, so we actually did an analysis, and our recommendation was, if your testing is going to be very limited, and the software that you want is supposed to have only sort of average reliability, then this is fine. Testing by operational profile is fine. But if you want highly reliable software, operational profile, using operational profile will not be the optimal choice. And however, if you want to get an estimate of the operational reliability, how it is actually going to behave during normal operation, then you need operational profile, right? Any questions on this? Now let me define the operational profile. Profile here, by profile I mean set up disjoint actions that the software may perform, and there are probabilities of occurrence. And of course, operational profile. Probabilities that occur in actual operation. And there are a couple of different ways people construct the operational profile. Sometimes they construct them by beginning to end operations. And sometimes it is given in terms of states and transition probabilities. So in this case, basically this would look like a Markov representation. So you have a number of states the software goes through, or rather the state diagram, like the finite state machine, and you have the transitions, and you calculate the probabilities of transitions. And you have to calculate that. You have to calculate the probabilities, and there are tools that will help you estimate the probability. So, for example, you can instrument your code, and when you instrument the code, by instrumenting the code, you mean you insert some code into your code which is going to run. So basically, you add some additional stuff into your code and then compile it, so that it will record how often certain branches are executed, and that will help you find these probabilities. Now it is possible that operational profile may be different for different applications. So there's one software, that's a spreadsheet, but there are people who are using spreadsheet for accounting, and then there are people who are using spreadsheet for scientific computing. And these two groups, they have different probabilities for using different functions of the spreadsheet. And accurate probabilities, people might think that in order to use these methods, you need to use accurate determination of the operation profile. But actually that is not needed, because results are not very sensitive to minor differences in operational profile. That actually has been established in a few studies. Now here's an example of an operational profile that was given by John Musa. So I borrowed it from one of his presentations, and he called it, here's an example of operational profile. And he calls it a phone follower software. So let us say that in some organization there is a PBX unit, and it handles the incoming calls. And there are total 7 types of operations. And the operations are basically they found you do a study and find out that let's say A voice calls, They happen 74% of the time. So let me write down percent here, so I don't have to write that here. Wait, that's wrong. Fraction of the time. Otherwise, I would write 74%. So I can do one of them. And let's assume that fax messages happen to be about 15% of the time. So 15% of the time, it is an incoming fax. And then, now this PABX system, sometimes you need to add things to it, and it has its own database. So sometimes you need to, I should have made this a column bigger. New number entry. Okay. New number entry. Sometimes you are entering new numbers, and let's assume that you do that 10% of the time. And we found that database audit whatever that is happens at 0.009 or 0.9% of the time, and E adds subscribers, and happens this often. So that is 0.05% of the time, and F delete subscribers, and that happens 0.000499. And sometimes your unit fails, so you need a failure recovery, and G is a failure recovery. And happens 0. Okay, how many zeros? 1, 2, 3, 4, 5, 6. No, wait. 1, 2, 3, 4, 5 zeros. Okay, I hope they all add up to 100%. Now I remember a couple of times we submitted a paper for review, and we had these numbers divided that add up to 100%. So a couple of times reviewer said, I added up your numbers and they don't add up to 100%. And that reason is that because you round numbers, right, which is common, and after rounding they don't add up to 100%. But then reviewers will, I guess maybe some reviewers don't want to work hard on trying to read the hard part of your paper, so that they will catch you on making sure that your numbers add up to 100%. But anyway, so I hope they add up to 100%. Okay, so here is a profile. You want to test this. So if you are using operational profile-based testing, 74% of the time you will test this, 15% of the time you will test this, and you will apply very few rare combinations to test for failure recovery. And you will do a little bit of testing here, but not spend too much time. Is that a good idea or not? Well, a failure recovery happens very rarely, right? So you don't need to worry about it too much, right, in terms of testing. Would you agree? How many of you would agree? Some of you don't want to agree, which is of course correct.
Because it's critical.
Pardon me?
Because it's critical, so even if it happens like very few times, it's critical for the...
Yeah, when it happens, then you do want to recover.
Yes.
So even though it happens on rare cases,